Hi everyone, welcome back. Let's see convoy effect in SJF algorithm. So before going for the definition of convoy effect, let me take an example. Process ID, arrival time, burst time. Let's take these two examples and we'll try to solve the average waiting time. So that we will get the clear idea what is going to be happening. Then we can define the technical definition of the convoy effect. So guys, how this SJF algorithm is going to work? Let's try to draw the Gantt chart first. So start with 0. By the amount of starting 0, is there any process is available? Only one particular process P1 is available. So it will be allocated directly. So P1 execute for 30 units will be done by 30. And by the amount of 30 units, both P2 and P3 are available. But their burst times are same. So it will be executed based on the arrival time. So P2 will be executed for 2 units of time, that will be done by 32, and then P3 will be executed for 2 units of time, that will be 34. Right? Once it's done, can you write the completion time, turn arrival time, and waiting time? Yes. So what is completion time of P1 will be 30, P2 will be 32, P3 will be 34. Turnaround time will be completion time minus arrival time. Turnaround time of P1 is 30 minus 0, 30, 31 and 32. Waiting time will be turnaround time minus burst time. 30 minus 30, 0. 31 minus 2, 29. 32 minus 2, that will be 30. Which means average waiting time will be 0 plus 29 plus 30 by 3. Approximately again 20 units of time here also. Right? So try to calculate for the second example. So 0 units of time. So by 0 units of time, process 2 is available. Yes. So it will be executed. By the completion of 2 units, P1 and P3 both are available. As we are applying SJF algorithm, which one will give the chance? 30 units of time or 2 units of time? 2 units of time. So P3 will be executed for 2 units done by 4 and then given chance to P1 for 30 units of time, that is 34. Now try to do the completion time, turnaround time and waiting time in quick manner. So completion time, turnaround time, waiting time. Completion time of P2 will be 2, P3 will be 4, P1 will be 34. Turnaround time will be completion time minus arrival time, 32, 2, 3. Waiting time will be turnaround time minus burst time, 2, 0 and 1. So if you look into the average waiting time, 2 plus 0 plus 1 by 3, which is equal to 1 unit. What does the meaning of these two examples clearly mention is, here it has taken the 20 units of time, here it has taken the 1 unit of time, as almost they are same. Why? Because why the second one is very less? It is because if you look into the burst time of the process P1, who has arrived early, is taking more time and not giving chance to the remaining process. Whereas coming to the second example, the shorter process are executing first, later on giving to the larger process. That's why it is giving very less waiting time. What is the meaning of this one? When a bigger process is arriving first, before arriving smaller process, then the smaller process has to wait for long time. This effect we call it as convoy effect, guys. Right? So which generally causes low CPU utilization. Is it right or not? when you look at the first example, waiting time of the process will be 20 units, and the second example, waiting time of the process is going to be 1 unit, which means I can say that it is going to have very low CPU utilization. And there will be one more factor is there, starvation. Does starvation is there in SJF? Yes. Why? There might be a chance to execute always the process which having the less burst time. Definitely the process which having the larger burst time is going to be in starvation state. That's the reason starvation and convoy effect are the two problems of SJF with preemption algorithm. But coming to FCFS, we are facing with convoy effect, but not facing with the starvation. Hope you understood the clear meaning of convoy effect and starvation in SJF. Thank you.